Assalamualaikum student. Today's topic is pressure. I am sure you have heard the term pressure in your daily life, right? Like we have exam pressure or work pressure, but in this class we are going to looking at what is the physics definition of pressure. I am gonna make the concept really easy for you, so student be sure to watch the entire video and I am sure you will find the concept really easy. So discuss the physical meaning of the pressure. So let us understand with example. You see the picture of the pencil here. When you take the pencil, right? So I have a pencil. If you pick up a pencil, the pencil, the pointed side hurt you. But if you touch the opposite side, the thick part of the pencil, it does not hurt you. So you feel hurt if you touch the pointed side. So discuss the physical meaning of the pressure. You see the picture of the pencil here. When you take the pencil, right? So I have a pencil. If you pick up a pencil, you know that the pointed side hurt you. But if you touch the opposite side, the thick part of the pencil, it does not hurt you. So you feel hurt if you touch the pointed side. So here the question arises, why sharp end of the pencil hurts? What we observe, if you put the hand here, it's hurt you, right? So sharp end of the pencil hurt. If you put a hand in the flat end, so let's see your hand is here, it does not hurt, okay? So you are applying the same force on the both side of the pencil. For example, you are applying 5 Newton force on both side of the pencil, so force is same. Then force is same, then why sharp end of the pencil hurt? So force cannot explain the why sharp end of the pencil hurt because force is same on both sides, right guys? If you notice that the sharp end of the pencil, the area is less. But if you see the other side, the flat end, the area is more. So here the reason is basically the area is less in the sharp end, so it connected to the area. So area is less on the sharp end and the area is more on the flat end. So guys, it does not only depend upon the force, it's also depend upon the area. So define the concept of the pressure. Definition of pressure is pressure is the thrust per unit area. Pressure is the thrust per unit area. So we can write it formula. Pressure is equal to thrust per unit area. So what's the formula of the pressure? Pressure is the thrust per unit area. Now understand the what's the meaning of the thrust. Thrust means perpendicular force. Look at the picture. Here we take a table. We put a rod on to the table. So you are applying the force on the rod here perpendicular to the rod. So force get transmitted onto the table. So when you are apply the force here, the force will be on the table. Okay, right? So now question is arise, force is perpendicular or not? Is it perpendicular to the table? What do you guys think? So you can see in the picture clearly the angle is 90 degree. So force is perpendicular. So this force is perpendicular. So this force is basically a thrust, right? So now we understand what is the thrust. Now we talk about the area. Here the area we use is not the area, it is the area of the contact. Let's understand with the example. When you take the pencil, if you press it against your palm, so force is perpendicular you are applying and the area of the contact of the pencil is in my hand. We can understand this area of contact on this example. Here the area of contact of the rod on the table is this, where the rod is contact onto the table. This is the area of contact where rod is touched onto the table. This is the area of contact. Is it clear guys? So that is what is the definition of pressure. So proper definition of pressure is perpendicular force divided by the area. Clear guys? So guys, can you tell me the SI unit of pressure? If you don't know the SI unit of the pressure, you can find it by using the formula of pressure. Formula of the pressure is the thrust per unit area. Here thrust is the perpendicular force and area is the area of contact. We represent the thrust by force and area by A. We know that the unit of force is Newton and the unit of area is meter square. So we can write that the unit of the pressure is Newton per meter square. So the unit of pressure is Newton per meter square. If you give the name Pascal, so you can write it in abbreviation. The unit of pressure is Pascal, PA. So guys, here the question is arise. How do we define? How do we define 1 Pascal? So just use the formula of the pressure. What is the formula of the pressure is force per unit area, thrust per unit area of the contact. So we know that if the force is 1 Newton and area is 1 meter square, it will be equal to 1 Pascal. So second question is arise. How much is 1 Pascal? Is it a large pressure or small pressure? What guys do you think? It is a large pressure or small pressure? Let's understand this question by example. If you take the one small page and put it on your hand, now you feel the pressure on your palm. The feel you pressure on your palm is 1 Pascal. That is very small pressure. So what we write, 1 Pascal is very small pressure. So that's why in physics we use the pressure in 1 kilopascal, 1 megapascal, because 1 Pascal is very small pressure. Now compare the force and pressure. What we define the definition of the force? Definition of the force is basically a push or pull, and the pressure is the thrust per unit area. What the unit of the force? The unit of the force is Newton, that abbreviation is N, and the unit of pressure is Pascal, that abbreviation is capital P or small a. Now force is a vector quantity and pressure is a scalar quantity. Pressure is a scalar quantity. It does not have a direction because pressure exerts in it all the directions. So it is a scalar quantity. Here the question is, in which position the pressure of the box is more? First position of the box is here and the second position of the box is here. Here we clearly see the force on the box on both sides is same. Force is same. When force is same, so you see the case 1, the area of contact of this box is larger and the area of contact of this box is smaller. So this is in the case 1 and this is in the case 2. So we can write the area A1 is greater than area A2. When area is greater than pressure is small, because we know that the pressure is inversely proportional to area. When area is less, pressure is more. When area is more, pressure is less. So we can write P2 is greater than P1 because here the area is less. So pressure P2 is more and pressure P1 is less.